All right, let's talk about a material that's so high-tech and so important, it's basically hiding in plain sight. It's in the jets flying over our heads, it's in our cars, and, believe it or not, it might even be inside our bodies. Today, we're doing a deep dive into the incredible world of titanium alloys.
So, here's a question for you. What could a massive, roaring jet engine possibly have in common with the quiet, delicate structure of a human bone? It really sounds like a riddle, doesn't it? Well, the surprising answer is they both depend on the amazing properties of titanium alloys. But what are these things really?
You can think of it like a recipe. You start with your main ingredient, pure titanium, which is already pretty impressive. But then you add just a little bit of other chemical elements, a pinch of this, a dash of that, and suddenly you've created something way better. A material that's stronger, tougher, and more versatile. That special mixture, that's a titanium alloy. So, what are these secret ingredients? Well, two of the biggest stars are aluminum and vanadium. They're the key players in the world's most popular alloy, which you might have heard of. It's called T6Al4V. See, aluminum is what we call an alpha stabilizer. It basically strengthens the material's internal structure, making it awesome at high temperatures. Vanadium, on the other hand, is a beta stabilizer, and it promotes a more flexible structure. That makes the alloy tougher and easier to form into complex shapes. Okay, so it's not quite as simple as one single recipe. Just like a great chef has different dishes for different occasions, engineers have different families of titanium alloys. And they basically fall into three main groups: alpha, beta, and you guessed it, alpha beta. And it really all boils down to a fundamental trade-off. You've got the alpha alloys, they are the absolute champions when it comes to handling high heat. Then you have the beta alloys, which are fantastic because they're easier to shape and weld. And the alpha beta alloys, well, they're the jack of all trades, a perfect hybrid that gives you an amazing mix of pretty much everything. And you can see those trade-offs in action right here. Look at the alpha alloys. Great at high temps, but you can't really make them stronger using heat treatment. Beta alloys are the total opposite. They respond incredibly well to heat treatment, which gives engineers a massive playbook of different strengths to choose from. And alpha beta, sitting there right in the middle, gives you that awesome balanced performance that makes it so popular. So all this chemistry, all this mixing and creating different families, what's the point? Well, the payoff is a material with some genuine superpowers. Let's break down exactly what makes these alloys so special. This right here, this is the big one. This is the property that puts titanium alloys in a league of their own. I mean, think about it. Getting the same strength as steel at nearly half the weight, that's a total game changer. It rewrites the rules for building everything from spacecraft to high-performance bicycles. This chart says it all, really. Look at aluminum. It's super light, but it just can't compete on strength. Then you've got steel, which is incredibly strong, but it's also incredibly heavy. Titanium alloys just hit that perfect sweet spot, giving you maximum power for minimum weight. When every single gram matters, there's just no contest. Okay, superpower number 2 is that it's practically immune to rust. And this isn't some special coating they add on top. It's just part of the material itself. The second titanium is exposed to air, it automatically forms this super tough, thin layer of oxide. It's like it has its own invisible, self-healing shield protecting it from the elements. And just how good is that shield? Get this. This quote tells you everything you need to know. After 16 years submerged in harsh, salty, dirty seawater, not a single trace of rust. It's just incredible. You can see why it's so vital for anything used in the ocean or in chemical plants. Now this next one, this might be the most amazing superpower of them all. Titanium alloys are biocompatible. And in plain English, that means our bodies don't see it as a foreign invader. They don't reject it. It can exist in harmony with our own bone and tissue, and that one property has completely revolutionized modern medicine. And let's look a little closer at why it works so well.
It's not just that it's non-toxic and doesn't cause allergic reactions. It actually encourages our own bone to grow onto its surface, becoming one with the body. Plus, its stiffness is remarkably similar to human bone, which helps reduce stress and promotes faster, stronger healing. It's just perfect for the job. So, with a list of superpowers like that, it's probably no surprise that these alloys show up in some pretty awe-inspiring places. Let's connect the science to the real world. Where can we actually find this stuff in action? First up, and most importantly, is aerospace. That insane strength-to-weight ratio is everything here. We're talking critical jet engine parts, sections of the airframe, the landing gear, anywhere you need to save weight to improve performance and fuel efficiency. Then, of course, there's the medical world. Because it's so biocompatible, it's the gold standard for things like hip and knee replacements, bone screws, dental implants, basically anywhere you need a strong, permanent part inside the human body.
We're also seeing it more and more in high-performance cars. Lighter parts like valve springs let engines rev higher, and full titanium exhaust systems can shave off a ton of weight while easily handling extreme heat. And you can't forget high-end sports equipment. From golf club heads that transfer more power to the ball to feather-light bicycle frames and tennis rackets, titanium lets athletes push the boundaries of what's possible. So who's the biggest customer for all this super material? Well, as you can see, while it's essential in many fields, aerospace is the undisputed king. It consumes the vast majority of all the titanium alloys we produce. Honestly, you can't overstate its role in making modern flight possible. But it's not all smooth sailing. You know, every superhero has their kryptonite, and for this super material, its greatest strength, being incredibly tough, is also its greatest weakness, because being that resilient makes it unbelievably difficult to work with. You run into three main problems. First, it's a terrible conductor of heat. So when you're trying to cut it, all that heat builds up right on the cutting tool and just destroys it. It's also really reactive when it gets hot, so it can literally weld itself to the tool. And finally, it has this weird tendency to work harden, meaning the more you try to machine it, the harder it gets. It's like it's fighting back.
Welding is just as fussy. And it all comes down to one thing. Contamination is the enemy. The process has to be perfectly, surgically clean. First, you clean the parts like crazy. Then, while you're welding, you have to bathe the molten metal in a shield of inert gas, like pure argon, to keep any air from touching it. And you have to keep that gas flowing until the whole thing cools down. Otherwise, the weld will be ruined. So when you step back and look at the big picture, titanium alloys are really the perfect example of a hidden force that pushes technology forward. By engineering materials at the atomic level, we can create things that are lighter, stronger, and more resilient than ever before, quietly shaping the future in ways we don't always see. And that kind of leaves us with one last big question. Not too long ago, titanium was this exotic, almost mythical material, and now it's essential to our modern world. It really makes you wonder, as we keep demanding more and more from our technology, what other hidden material is out there right now, just waiting to be discovered and engineered into the next thing that changes everything?